Hi everyone, and welcome to our video on solving absolute value equations and inequalities. We'll get to the inequalities in just a bit. By simply using the graphing calculator and visual cues. So in your packet, if you have the Unit 4 packet, you're going to be right here with example 3. You're going to be doing example 3, example 4, and example 5. I'm actually going to do these 3 examples on a separate sheet of paper because I like to write really big. So you'll be putting it onto your packet. If you don't have your packet, you can do what I'm doing and just do it on a separate sheet of paper. So the first example says solve for x, and the equation is that the absolute value of x equals 6. And we're going to go at this from a completely graphical point of view. So I want you to grab your TI-84, as we have done many times in this unit and before. Turn it on, and let's go into y equals. So press y equals. Let's clear out the old junk, get a clean slate. And as we always do, in y1, I want you to type the left side of the equation. So we're going to type in the absolute value of x by hitting math, arrowing over to num, and then coming number 1, ABS. Okay, so the absolute value of x, we'll get that in there. And then in y2, I would like you to type the right side of the equation, which is 6. Now, before we even hit graph, we have graphed both of these types of equations before. We know that the absolute value of x is going to make a V shape, and we know that the line 6 will be horizontal. So what we're going to be looking to find once we get this graphed is where the V shape hits. I think of equals as like touches or hits the horizontal line y equals 6. So that's what we're looking for, where this one equals this one. Where do they hit or where do they intersect? So let's take a look. So let's press graph. Okay. Now your window and my window might look a little bit different because I think I've been messing with my window. So I'm going to go ahead and press window and set it back to default. As you can see, it is almost at its default, except I want to change the Y max back to 10 so that we look more similar. So now we should look the same. So there's my V, and there is the horizontal line. So to figure out where they hit, where they intersect, where they're equal, we're just going to go and grab this point right here and this point right here. And we've done that many times. So second trace, number 5. First curve, enter. Second curve, enter. And I'll pull to the left for my guess here. I like to go left to right, so let's hit it right there. Hit enter. And you can see that the x value of this point, so if you drop this down to the x-axis, x is -6. So that's going to be my first solution. X equals -6. Now I do have a second solution, second trace, number 5. Enter. Enter, and my next guess comes all the way over here to the right. And once I get there to the point of intersection, hit enter, and I see that my x there is +6. So if I were to drop this down to the x-axis, I'm at x equals 6. And just like that, I have my 2 answers. Now, could I check it? Sure, granny style. I could totally check it. If you wanted to check this one, you could simply take each of these answers one at a time and fill them in for this x. So if I check -6, the absolute value of -6 is supposed to equal 6. Let's see if it does. Well, the absolute value of -6 means how far away from 0 is -6? Well, it's 6 away from 0. So this is 6 equals 6, and that's a good one. And then we could also check the second solution, +6. So we fill that in for this x. Does the absolute value of 6 equal 6? Well, how far away from 0 is 6? It's 6 away. So 6 equals 6. And we've got ourselves two good answers right here. So that's it. Okay, let's go to the next one. This would be example 4 if you're using your packet. So if you're using your packet, example 4 says, solve for x. But this time it's an inequality. It says the absolute value of x is greater than or equal to 6. So this makes it a little bit different because of this guy right here. But we're going to go about it pretty much the same way. So in y1, we already have the left side, absolute value of x. In y2, we already have the right side, 6. So the graph on the screen doesn't change. What changes is how we have to interpret this graph. So let's come over here and take a look. So what this is really asking is, hey, find the x values where the V shape is, I'm going to use the word above here, above or equal to, because greater than or equal to would mean above it, greater, above, or equal to because of the equal to. So the V shape is above or equal to the horizontal line. So let's look at that. Let's come over to the graph. So here's your V shape, here's your horizontal line. Where is the V shape above or equal to the horizontal line? So can you tell? We already know it's equal to here and here. But then it stretches above here and also here. So if I were to draw this, now you can actually draw it on your packet because I have a graph there for you, but I'll just kind of draw mine freehand here. So if I were to mimic this here, I've got this V shape, right? Got the V. And I've got the horizontal line, which comes through here. I'll do this in a different color. Here's the horizontal line. Now from the previous example, I already determined that this point of intersection occurred at -6 on the x, and that this point of intersection occurred at +6 on the x. What I'm saying is the V shape is above the horizontal line from this 6 and to the right, and from this -6 and to the left. So how would I write that as a solution? Well, if I'm going from x equals 6 off to the right, I would say my x values, I'm solving for x, my x values would have to be greater than or equal to 6. And then back here, if I'm moving from -6 to the left, then my x values would have to be less than or equal to -6. Again, that shading here, this red, is everywhere to the left of -6 or to the right of +6. And because these are in two very different places on the graph and there's no connectivity, I mean, you're here or you're here, we actually put the word or between the two. So this is the solution, these two. That is the answer to this absolute value inequality. Now, if you wanted to check it, you sure could. You would just check it by putting some values on these intervals in for x. So for example, if I choose something over here, maybe x might be 10. Like say I go out here to x equals 10. That's definitely going to be, if I trace up to the graph, that's definitely going to hit the red shading. Now, if I put 10 in for x, I would have the absolute value of 10 is greater than or equal to 6. Let's see if it's true. 10, the number 10 is 10 away from 0 on the number line. So 10 is greater than or equal to 6. That's a true statement. And then if I pick something over here, maybe I come on out here to negative 10. Let's see if negative 10 works, because negative 10 as an x value would be part of this piece of the graph. So if I do the absolute value of negative 10, and again, I'm going back to the original. Always take these back to the original to check. Has to be greater than or equal to 6. These just help me choose my x's that I'm testing. Negative 10 is 10 away from 0 on the number line. 10 is greater than or equal to 6. So that's a good solution. So I'm checking these two intervals and it's hooking up and working out. So that's great. Okay, and our last problem, this would hook up with example 5. Again, you can do it on your sheet. I'm just going to use a separate sheet. Example 5 is saying, hey, what about if we solve for x, but this time the absolute value of x is less than 6. Okay, we already have the graph, you guys. It's the same darn thing. If we go back to the graph, we've got the v and we've got the y equals 6, the horizontal line at 6. So again, the graph isn't changing between these examples. It's just the interpretation is changing. So now I'm looking for where did my red pen go? There it is. I like my red pen for this part. Now we're looking for where, let's see, the V shape sits below, less than, where the V shape sits below the horizontal line. So let's take a look at that, where the V shape sits below the horizontal line. Well, here's the picture. Here's the picture. So we don't want to know even where it's equal to. This does not have an equal to. So like I'm not going to count that point because that's where they're equal. And I'm not going to count that point because that's where they're equal. I just want to know where the V is underneath the horizontal. So I'm going to have to say right here, this little piece. Pretty much the piece that was left over from the last example. So what is this piece? Like, where is this piece with regard to the x-axis? Well, if I'm drawing it on my paper, let's see. So if I'm just going to sketch it, and again, you can sketch it on your graph, on your packet. You know, you've got this guy right here. Here's your V. And then you've got your horizontal here. Now, we don't want to include these. So I'm going to open those up. We don't want to include those because we don't want to know where it's equal. We do know that this is negative 6 on the x, and we do know that this is positive 6 on the x. And we want to write our solution as everything here, where the V sits below the horizontal. So the easiest way to write this solution, since it's between negative 6 and 6, is like this. I put the negative 6 on the left because it's on the left. I put, let me scooch out a little bit. I put the positive 6 on the right because it's on the right. My solutions, which are these guys, I'm solving for x. My solutions are in between. It's kind of cool how you actually sit the x, the solutions in between negative 6 and 6. Now, we know that we have to be less than 6 because we don't go greater. There's no red out here. We're actually going this way with the 6. So x is less than 6. But at the same time, with regard to the negative 6, we have to go this way with the negative 6. So we have to be greater than negative 6. That makes sense because if you're less than this but greater than that, then you're in between. But what do we do here? What symbol do we put here? Do we put it greater than? Let's think about that. If we were trying to write x is greater than negative 6, which is what we're trying for, but we turn it around 180 degree flip, because as you can see now the x is on the right side of the negative 6. So if you flip this around 180, then the symbol would also have to flip. And so this is how you write your x values or your solutions sit between -6 and 6. Very cool. So that is the answer. And just to check it, we could pick any value of x in between -6 and 6. I don't know. Why don't we choose 1? 1's an easy one to use. So if I were checking this off here to the side, and I put 1 into the original, I would have the absolute value of 1 must be less than 6. The number 1 is 1 away from 0 on the number line. And 1 is less than 6 is a true statement. So that's great. Anything you choose, any x value you choose, you just have to map it down to the x-axis. Any x value that you choose in this red region is going to make this inequality true. And then the final item that I have actually in the packet is just a reminder. This would be from your math past. You definitely have seen number lines representing solutions to compound inequalities. So I just wanted to remind you, if you were writing the solution set for the inequality that's graphed below, you might initially say, well, let's see, this red is all values of x that are, let's see, we're going this way to the right of -6. So x is greater than -6. And because the shading is between two numbers, so we use the word and with this guy, with the 6, we're less than +6. Less than 6. So in your math past, you may have written it like this. That's called a compound inequality because you have two inequalities in your statement. But again, like I just reiterated on the last example, sort of the more mature way, I guess, of writing that is, again, to put your x between the two numbers the solutions sit between. And then simply point your symbols both to the left. And as long as you go low to high, that's always going to work out. If you cover up this side, there you go. X is less than 6. That's this part. And then if you cover this up, this means the same as that. They're just twisted around 180 degrees. So it works out perfectly. So this is what we're shooting for. This is the way I'd like you to think of writing that when your solutions come between two numbers. Okay, cool. So for the mastery that goes with this, if you're working on the Unit 4 packet, this is the mastery. Just gave you 3 problems very similar to what I just did. And I simply want you to do it all on your TI-84. So I want you to look at the graph and tell me when the V equals 5, when the V is above 5, and when the V is below 5. And then when you check your answers, hopefully we match up. All right, great. Thanks for watching.